Are you guys here for the USC presentation? I hope so, because that's what we're going to be talking about today. So it's going to be split off into two sections. First, I'm going to just give a brief overview of USC. I just want to get can you guys raise your hands if you guys have already gone to one of the USC presentations? If you already know what USC is about? If I can just see a show of hands. Anybody? 1, 2, okay, so there's about 3 people here who have not heard of USC. Okay, so then I'm gonna start off by talking a little bit about USC and what it's about. And then I'll follow that with a demo of USC, how you can use it, how you can install it. And then we're gonna spend a bulk of our time just kind of opening the floor for people to provide input on what sort of southbound plugins they want USC to support and how they would like to see USC move forward. So this is we would like some more community feedback. So let's begin. So USC stands for Unified Secure Channel, and it's a collaborative project within OpenDaylight. We are part of the Lithium release and moving forward. USC enables a unified, secure, and high-performance communication over many different protocols between the SDN controller and network elements across the internet or unsecure public infrastructure. Basically, what we do is between your SDN controller and your enterprise edge nodes, we create this tunnel. The single unified tunnel that is shared by all the different protocols and southbound plugins. So now all the different applications will have different sessions through that tunnel. And that tunnel, we provide different additional functionality, like higher security, where we provide encrypted communication and mutual authentication. We also provide better performance through the use of protocol multiplexing and converged tunneling for all protocols. We also want to support large capacity by supporting southbound clustering. And I'll get into southbound clustering later. And also elastic scalability to satisfy different capacity requirements. Okay, so this is the architecture for USC. There's 5 main components to it: the agent, the plugin, the manager, the API, and the UI. The agent sits on the device. And in Lithium, we have both a Java-based agent and also a C-based agent. And the USC agent basically acts as a protocol proxy between the controller and, say, the NetConf server, the SNMP server, the CAT web server. And hopefully in the future, we will want to support other things like OpenFlow and MQTT and any other southbound protocols. The USC agent also does the muxing, demuxing, TLS, DTLS, but it also acts as a call home client. So it's going to initiate a connection to the controller. The USC plugin sits on the controller. It's Java-based, and it acts as a session manager. So it coordinates all the different sessions from different southbound plugins or applications. And it does the protocol handling, muxing, demuxing, TLS, DTLS. But it also acts as a call home listener. So it's actually listening on a particular port. And whenever a call home request arrives, it responds by creating an outbound connection to that device. The USC plugin sits below the different plugins here. So from the southbound plugins perspective, it's all transparent. It just runs through the plugin and the agent. We also have a USC manager, which is responsible for security, clustering, config, and monitoring. And then we expose a REST-based API to and also a USC UI, which is based on Deluxe. It uses the Lithium Deluxe modularity to install its UI into Deluxe. And we're one of the first projects to do that. The 4 main key features of USC in the Lithium release is protocol multiplexing, call home, mutual authentication, and enhanced clustering. So let's talk about protocol multiplexing first. Typically, each protocol will establish its own connection between the controller and the device. So you may have a connection, a netconf connection between the controller and the device, and then you may have another SNMP connection, another CapWeb connection, et cetera. What USC does is it comes in and it creates just one tunnel and one connection between the controller and the device. And all those different protocols will share that connection. And this is done using a USC header, which has an overhead of about 8 bytes. This means that you only have to do one authentication handshake, one asymmetric authentication handshake. And then after that, it's just basically symmetric encryption between the controller and the device. So the second feature that USC offers is call home. So a lot of enterprise will have their devices behind a firewall or a NAT. This means that when the controller tries to reach the device, it's actually unreachable. So what we do is we were inspired by the netconf call home. In USC, the agent initiates a call home request to the controller, and then the controller will establish a channel to that device. And that's how we achieve call home. USC also offers mutual authentication in Lithium release. This is because you don't want a rogue controller to come in and start controlling and managing your devices. You want the devices to authenticate the controller, but you also want the controller to authenticate the devices. So we put certificates on both the controller and the devices, and that way we get mutual authentication. We also offer something we call southbound clustering, which is different from the MD-South clustering that Moz and the controller team are working on. This is about southbound clustering. So the idea here is you have a 2-node cluster, controller 1 and controller 2, and you have an app that's talking to node 1, but you have a device that's already connected to node 2. It already has an existing connection between the device and node 2. So an app comes in and it sends a request to configure the device to node 1. What you don't want is node 1 to initiate yet another connection to the device. What you really want to do is reuse the existing connection. So what USC does is it comes in and it routes that message from node 1 to node 2. And it does this because it maintains a table mapping between which device is already connected to which controller node. So then it routes it to node 2, and then node 2 sends it to the device, and it comes back to the app. And so that's the southbound clustering feature for USC and Lithium. To install USC, basically all you need to do is just install the ODL USC channel UI carafe feature. After that, you get all of the USC features, and you also get the UI so you can see your USC deployed environment. Of course, you're going to have to do some configurations for USC to work properly. We have a folder, a certificates folder, inside the ETC folder. And this is where you want to put all of your certificates. And we have an akka conf file where you want to specify your clustering-related properties for southbound clustering. We also have a usc.properties file, and in this one, you specify the location of your certificate. So if you don't like the default location that we use, then you can specify your own. We also define the location of your akka.conf file and various other default properties in USC. If you want to use USC with netconf, you're going to have to go into the etc OpenDaylight carafe folder, I believe. And there's a file called 01-netconf.xml. You're going to have to go in there and change it to use the USC netconf dispatcher. By default, it uses the netconf dispatcher, so you're going to have to replace it to use ours. And from there, you can use netconf with USC. So now I'm going to switch over to a different computer which has USC installed. So I'm going to switch over here. USC, and there are some similarities between USC and VPN, but on top of that, we also provide certain other functionalities like southbound clustering. That's something that VPN doesn't offer. So USC does more than that. And yes, we also provide call home. The thing is, not every protocol has call home in its specification. So what we want to do is we want to have ODL adopted by enterprise customers. And a lot of their deployments are behind NAT or firewall. So that's why call home is very essential, an essential feature to enterprise customers. So yes, there are similarities with VPN, but we add additional features on top of that. Does that answer your question?
Yeah, okay. Maybe I'll, since we have a little time, the cable modem industry, all these cable modems sort of speak layer 2, and just layer 2 only. And people have been talking about. This is the question I asked yesterday. Okay. I'm sorry, I missed that question. I don't want to pull them down.
Go ahead. Yeah, do you have a microphone for people in the audience to talk back?
That's okay. I mean, you can go ahead with your demo. Let's go ahead.
That's the sort of standing question that I have, or issue that I have with this argument.
Okay, good, thanks.
Yeah. Okay. All right, so in this demo, I'm gonna start Carafe, and I'm gonna install USC. So it's gonna take hopefully not too long. So here I'm installing USC with RESTconf, API docs, and Deluxe. All right. So right now it's just installing all the features. So now I'm going to the API docs website, and I'm gonna scroll down to the USC APIs, and I'm going to add a channel. But before that, I want to show you what on the Deluxe UI. Right now, there are no channels because I just started USC. So from here, let's see. Oops. All right, so now I've created a channel in a session through the API. So now when I reload the UI, we see that the channel and the session has been created. So next, we're gonna go and send some data through that. So I sent over some sample data, and when I reload the UI, then you'll see that the bytes have gone up. And here we go. What?
What is your agent? The
Yes, so I'm just gonna go to that. So right now, I don't have a netcom server, so I'm using the USC test agent and test echo server. So if you download the USC source code, we have a a class called USC Agent TCP. This is our Java-based agent. And it really should not be used in production. This is really for testing purposes. It's really a reference implementation. So I already have it running, but from Eclipse, you can just go and run as a Java application. And you have your test agent running.
From security perspective, how you trust your agents, like using certificate, you use certificates from third party to
So
authenticate your agents?
yeah.
Details.
So you'll want to purchase some legit certificates in your productions environment. But right now, what we did was we had self-signed certificates, one set on the agent side. We put it in this folder right. Let me find a folder. It's in source main resources etc USC certificates. There we go. So this would be on the device, the agent side, and then you would have another set on the controller side, and that's located. Let me show you the location of that one. That's located under ETC USC certificates. There we go.
So basically, the agents will be in the gateway of the network.
Yes.
But what about the endpoint itself? Like, you need endpoint compromised, like, how you can prove this kind of security, how you can handle this kind of threat application.
Yeah, at the moment, the scope for USC is just to securitize the communication between the SDN controller and up to the gateway, like say, for example, an IoT gateway, right? But what you're asking is how do you authenticate the devices that's connected to the gateway? Is that the question?
Yeah.
So we haven't, that's not yet just part of the scope of USC, but maybe if we get some feedback from the community, perhaps we can expand the scope.
I mean, your controller could be compromised, like if the endpoint can be compromised, the gateway, it would be easy to go through the controller, like the agents in the gateway and the endpoint should be like have kind also of mutual authentication.
Yeah.
Because in that way, your controller itself, like being
Yeah, I see your point.
flow, like so.
I mean, that's going to be true end-to-end, right?
Yeah.
I mean, the point is that you're talking about encrypted channels just between the agents and the servers that are run from the controller. But really, you're going to have to then negotiate your APIs and your interfaces to. I mean, there's a lot. You've got a channel, you've got communication channels throughout the layers.
Mm-hmm.
Right? So all of those are going to have to be connected. Right? I mean, to claim that this is a secure channel, right? Those are all possible vectors, right?
Yeah. That's definitely a good next step for.
It's just something. I mean, this is the kind of thing that gets obnoxious to administrators, right? Because now they have all this bookkeeping that they have to take care of at each one of these interface layers, right? So you got to track all your certificates. You got to make sure that they're renewed on time, right? Because otherwise, you have expired certificates and people can't get in and you're knocked off. I mean, it's kind of a hassle. So.
In some kind of ways, this is first release. So we just wanted to get the concept all rolling, and then that's also we put this kind of topic here in this kind of discuss. Wanted to get more kind of feedback and participation, but our goal is like design a kind of framework over here, and then in the next release, even in the release, we could put like the framework. We could integrate with AAA, with some other depends what kind of authentication you want to use, like industry standard or some kind of other sense, then could very easily plug in and use leverage that kind of API, some kind of things like that. Like first we could integrate AAA and also like a radius if you wanted to with the AC and also UOP, that kind of communication. And also for the IoT, there's maybe more things. We could pick up some kind of most has higher priority for you and implement that, then people could put more kind of like a driver's little sense over there for themselves. And you download this software, free software, and then you add your own sense, and then you could sell. So that's the whole idea.
As soon as you tie the word secure to your session, you automatically make yourself a target for people who are interested in breaking things that are secure, right? It's just, that's, I mean, oh, you're secure. Oh, well, we'll see about that. And so I mean, at that point, you have to start thinking of people not using your software the way that you intended it to be used, but people are going to try to misuse it for their own purposes, right? So you have to. So at that point, you have to start putting your mind in the mindset of somebody who intends to do you ill, right? So I mean, and as soon as you put the word secure on there, right? That's, you just sort of you create a big target on you, right? That says we're you're it's open season, right? So that's why I say that the more software you have, especially as it's distributed, right, across different components of your architecture, the more bookkeeping you have to do with all of these different pieces of security, right, that you have to maintain, right? And so, I mean, you're talking about Radius, you're talking about AAA. Those are all good things, right? The problem is that it just starts to become more and more of an administrative problem for the people who are supposed to operate it day to day. So when I look at this, that's the concern that comes to my mind, is how do you make it secure without making it impossible to use or administrate?
That's a very good point. Have you done your demo? Or we
Yeah, I'm done with the demo. Maybe just kind of opening up for questions and answers at this point.
So maybe then we could kind of like openly kind of discuss on this. For example, like that's very fun. We got a target, then we get people attack us, then we could get our algorithm better. That's a fun part, but definitely over here as we defender, then how we could get that one stronger. So there's some kind of thought on that is right now we choose the TLS, DTLS, the kind of standard library for the security to get the mutual authentication for that. And also like we all know the TLS and DTLS, maybe it's not at layer 2. Layer 2 is kind of another way to also to make the things secure. Definitely I agree with that. But right now with the software-based solution. And also, a lot of kind of protocols, kind of some other things, then people will find more in the software kind of way at layer 2. For example, the other day we discussed how we could leverage analytics. Like how the analytics specifically for the security, like some kind of intrusion, some can analyze, like those kind of things, how layer 2 could leverage that. But for the OpenDaylight, as an OpenDaylight project, for us it's kind of very easy, kind of find a solution at a layer 7 to use a software kind of way. Definitely we could find more ways to how to do it. First of all, we want to use some kind of open standard, pretty mature in the industry. TLS, DTLS, and also it's free. And also in most of kind of, like right now, our agent run on the Linux system. Most of Linux system already have the TLS, DTLS over there. You don't need to install anything extra. So that's kind of some kind of assumption before we had. But of course, if there's more sense, we definitely wanted to make this framework flexible enough to, like your commercial solution, how could you integrate with some kind of sense, even talk with their L2 solution. like how this sense could, like the whole pipeline, that kind of something. I think is very, very interesting point.
So would it, just if I understand it correctly, I guess
Maybe we don't.
all right. I mean, maybe I'm just asking an understanding question. You were mentioning sort of the phone home feature through firewalls and such. So if I had an OpenDaylight controller back behind a firewall, and maybe I had some router that, obviously I could manage with netconf or whatever, but if I had USC running and a certificate appropriately placed on the router, it would be able to connect across a disparate network, a little bit like a VPN, so to speak, and phone home to the OpenDaylight controller? Okay. Yeah, okay, great. I mean, I think that's a good problem to solve, right? I mean, that's an important problem, I think, that needs to be solved, and this looks like it does provide that solution, so.
Yeah, that's what we can solution. We specifically talk about like IPsec kind of sense. Like before, we also say we can, like even I look at GRE and also other solutions over there. The problem is like for the big enterprise, we definitely could leave that kind of possibility. You use kind of VPN technology, but the thing is like for the VPNs, and a lot of time you need to get the connection. You need to get the SLC to make sure get enterprise level like the IPsec, that kind of sense, the agreement to get all those kind of security things happen. If that sense, if something you really need that, we definitely also trying to make the framework could leverage that. Because really you don't need to restrict what kind of technology you want to use underneath. So that's the goal.
Another option that you have is that you can look at IP version 6.
We actually right now support IP version 6, but the thing is, anything specific you talk, IPv6 has for security.
6 makes it a little easier to tell. So if you wanted to do layer 3 over IPv6, that's just another option that you have.
Yeah.
Right? I'm not saying that it's necessarily the right one.
Right.
And there are other layer 2, there's open source layer 2 funneling tools that are available there.
Maybe you could give us that kind of list, or you could participate to see if how that sense also be one possible solution for this. Because,
And the thing is that
right,
that your agent solution ultimately won't prove to be the right one. Right? I mean,
we could also prove it's the wrong one. That's also okay.
the thing is that there may not be right or wrong. Right? It may just be
One,
options,
yes,
right?
exactly.
So, I mean, the thing is that what you're offering is an option. And ultimately, I think that really this is sort of I'm fairly new to the open source development side of things. I've been a user of open source for a long time. But I mean, I think the point is that you throw it out there and you see what sticks, right? Right. So the thing is, I'm not trying to discourage you, right, from distributing a package that includes your agents. All I'm saying is that these are the concerns that occur to me, right, with this package being adopted, right, if you do that. I mean, it really wasn't meant to throw cold water on the whole thing. It's just to say, these are the issues that occur to me.
Well, we definitely value the feedback. Any additional feedback actually helps us improve USC and expand on it.
Okay, so the other thing I did want to ask you about was performance. Okay, you mentioned that you have a C version, which presumably is faster than your Java version. But I mean, are you sort of leaning toward one or the other right now?
The C version is, there's some licensing issue. The C version is GPL'd. So we can actually include that C version into OpenDaylight, which is part of the Eclipse license. So that's why we actually put the C version on GitHub for now. And the Java agent is really for testing purposes at the moment right now. Yeah.
So does that include do you have C version for your agents?
Yes.
Okay, so I'm assuming then that
team, kind of most of the developers are Java developer. So we actually believe Java is faster, but the problem when we talk with the device people, because the agent needed to run either as an IoT gateway or on the access router or something on the edge, right, or to the enterprise edge somewhere. When you run that, their device cannot provide us a Java runtime. The smallest Java runtime library is 55 megabytes. So they don't allow to put some kind of big footprint for that. We actually prefer to get the Java agent and to make it super fast. And also that kind of agent could run on the device. So that's kind of limitation. But the device developer, the C developer, trying to convince me C is faster, so I just take it. But I didn't do the benchmark. I assume at least it has smaller footprint. That C agent is developed based on the S tunnel. Yes, that one, it's kind of pretty small, but because of library compatibility. But for the things for this project scope is right now we implemented SMP and LibConf, but we are trying to, like, if we talk about the problem domain, we said that we want to target in future enterprise the problem, the ICT convergence, the IoT problem between your controller and the device. You might run very kind of protocols, like even some kind of data. So the performance, that's why especially IoT use case, the performance is very important. It needed to respond very fast as a change and all those kind of things.
Like the first step, like once you have a security channel established,
Yes.
like the performance not a big deal for the security channel to resist. Like I mean, it's not like a big problem for you, the performance to establish the connection, because once you establish the connection, you use another protocols to perform whenever you want.
Yes.
So it's okay, like.
But the things we said is we want to reuse the connection. We don't want to. If you look at the one of the diagram we have, like without this, if between the controller and the device, we have a couple of protocols. Right now, without this kind of solution, in fact, this one is also not the only solution. Like say in the industry, there's some kind of product already do that. They do the multiplexer capability, trying to leverage the same connection with multiple protocol inside that. This one just kind of open source version. So like the gentleman said, this is not only one of good, better. It's just one open source option over there for the community. You could do, and maybe we could use it to prove a concept in some kind of ways. So you don't need to, like, if between the controller and the device, there are 5 protocols run inside. Right now, if you don't have this solution, each time each protocol communicate with this, they will do a new, like authentication,
Yeah.
repetition authentication.
This is bad. This is the way wrong. We should not do it like that.
Then you will need to do it again. When they don't need that, then you will do it again. And also, that's why this only multiplexer plus the clustering enhanced on the southbound to make it performance better. Yeah, because for example, in the future, I cannot imagine your solution, the real industry solution is only one controller. You always have a cluster, and especially the trend of scale out. You don't want to buy a super big controller servers over there. You have a couple of them to get your HA, and then without this kind of solution, if the node 2 connect with some kind of device, node 1 is not connected to that. Right now, it's just say you do this, and then before it has a tunnel, then I have to create another one. So right now, the things we just keep one live connection and make sure even in the clustering environment, it always could reuse the same connection. So that's why all those kind of things could add together, improve the performance. I'm not sure, yeah.
And now can I use the agent? In which device can I deploy the agents now? The version that you have?
As long as your Linux, maybe we have somewhere documented the Linux version we tested with, right? You know the Linux version C has to compile with specific versions, not like Java. It's much easier. The C, we have Linux version we fully tested. Maybe with the other version, it really depends. Like the agent is developed on top of S channel. So the dependencies, what S channel works, maybe R sense most likely work, but we still need to test more.
So I got a quick few questions on the practice that will implement that. The first one is that you're doing end-to-end tunneling, right? So how this one will be coincide existing infrastructure like a Linux stack? Because you're using it, you're bypassing it. That's the first question, because you're doing the protocol maxing, right? The first one. The other one, you're building a secure channel. So as the other gentleman said, how that one coincides with VPN in your system. Okay, coincides. The other one is a protocol multiplexing, how that one differentiated from the Linux TCP/IP stack. So you're coincides, or you're on top of that, or bypassing it. The last one what I ask is that you're doing the protocol multiplexing, how you how to leverage on the application, because application in your system may be multiple different application using same protocol. Are you doing next level, the max, or how you implement that?
So maybe if we could go together a little bit so that we could fight for some kind of sense like that. So I hope I can answer some and deliver all your questions. Right now, how it works is like, I'm not sure if you slide we talked about, we have a USC header. Our solution
So we're actually out of time. If there are no other urgent questions, but feel free to come talk to us offline. We have a wiki and also a mailing list that you guys can reach out. And definitely, please come participate, collaborate with us. All right, thank you so much.